In this video, we're going to cover section 4.5 on exponential and logarithmic equations. This will be part 2 of section 4.5. We covered exponential equations in the first part, and we'll look at logarithmic equations in this second part. For our first example, we have the logarithmic equation log base 7 of x squared plus 3 is equal to log base 7 of x plus 4 plus log base 7 of x minus 1. And here, to solve this, first thing I want to do is look at the right side, and we notice that this is log base 7 of x plus 4 times x minus 1 on the right, when we can combine the logarithms here. And if we continue on the right side here, we can combine this and multiply the x plus 4 times x minus 1, and we in fact get x times x is x squared, 4 times x is 4x, x times negative 1 is negative 1x, so this is a plus 3x, and then 4 times negative 1 is a minus 4. And here we have log base 7 of x squared plus 3 is equal to log base 7 of x squared plus 3x minus 4. So if these two statements are equal, then the insides here must be equal. So in fact, we have x squared plus 3 is equal to x squared plus 3x minus 4. At which point this just becomes an algebra problem to solve. 3 is equal to 3x minus 4. So 3x is equal to 7. And we get x is equal to 7/3. All right. So I want to look ahead at a second example here. Zoom out just a bit so you can see. And then for number 2, we have the example log base 10 of 7x plus 6 is equal to 1. And here, if we don't write the base, again, that is assumed to be log base 10. Well, what we can do with this is we can take 10 and raise it to each side of this equation. So we have 10 raised to the log base 10 of 7x plus 6. And on the right, we also have 10 raised to the first power. 10 raised to the log base 10, those just cancel, right? Those are inverses of each other. So in fact, we get 7x plus 6 is equal to 10. And therefore, we can subtract 6 on both sides, and we get 7x is equal to 4, so x is equal to 4/7. We can move on to a third example here. And we have log base 2 of x plus log base 2 of x minus 2 is equal to 3. And we want to combine what we did in the first two examples here. So the first thing is, up in the first example, we combined this logarithm. So this is going to be log base 2 of x times x minus 2 is equal to 3. And from there, now we can take 2 raised to each side of this equation. So we have 2 raised to the log base 2 of x times x minus 2 is equal to 2 raised to the third power. And here, the 2 and the log base 2 cancel. So this is just x times x minus 2 is equal to, and then 2 cubed is 8. So we get x squared minus 2x is equal to 8. To solve for that, we move the 8 over. And here we have a quadratic equation we want to solve. We may notice that x squared minus 2x minus 8 is factorable into the form x plus or minus something. All right, what do we need? We need two things to multiply to be negative 8 and add to be negative 2. Well, we notice that negative 4 and positive 2 will satisfy those conditions. So we have x minus 4 times x plus 2 is equal to 0. If that's the case, this implies that x is equal to 4 or x is equal to negative 2. And so there we have actually two solutions. Actually, we do not have two solutions. Once we look at these two possible solutions, we should verify that these work according to our original statement. If we plug in 4 into that original statement, log base 2 of 4, that's an allowable input. Log base 2 of 4 minus 2 would be 2, and that's allowable as an input to a logarithmic function. But if we plug in negative 2, we can't have a negative 2 inside a logarithm. So in fact, x equals negative 2 is not a solution. So our only solution for this problem is x equals 4. There is one more question I want to do from this section, and that is an interest problem. So this is a person invests $6,300 in an account that is compounded continuously and pays 5% interest. Okay. So the first question is, what is the amount after 2 years? Well, we want to use the continuously compounded interest formula. So that is A of t is equal to P times e to the RT. Again, P is the principal amount, which is our initial investment amount. R is our interest rate, and T is the number of years. So we get A of 2 is equal to 6,300 times E raised to the 5%, so that should be 0.05 times 2. So this is 6,300 times E raised to the 0.1. And then you would plug that into a calculator. I haven't done that here, but you can do that to find what the decimal form of this answer is. For part B, we want to ask, how long will it take for the amount to be $9,000? And here, we want the final to be 9,000, so that's our A of t. So we get 9,000 is equal to 6,300 times e raised to the r, which is 0.05, times t. And t is what we don't know. That's what we're looking for in this problem. So the first thing we can do is divide by 6,300. And if we do that and reduce, we get 90 over 63. If we divide the numerator and denominator by 9, we get 10 over 7 is equal to e raised to the 0.05 times t. Take the natural log of both sides. And we get ln of 10/7 is equal to 0.05 times t. You might notice that 0.05 is the same as 1 over 20. So we can in fact just multiply by 20 on both sides to get rid of that 1 over 20. So 20 times ln of 10/7 is equal to t. And again, if you needed this in a decimal form, you can just plug that into your calculator. I would like to point out that before this section, we could have done part A here, but part B here is a new example. This wasn't in any previous sections, because now we had a logarithmic equation here and we needed to solve. And we did so by taking the natural log of both sides. All right, I believe that is it for this section. So next time we'll be looking at 4.6.